Hello, guys! Hello, everybody! Welcome to my YB channel once again. I was interrupted for a long period of time because of my laptop setting due also to weak connection of the network provider. And now I've managed to fix the settings and I still don't know. Maybe it will come back later on, but let's try to observe if it happens again or not. Okay? But let's just pray to God that it will not happen again because it took a long time, really a long time to do that. It's very tiring trying to do that also, right? Really. Okay. Since I have this passion, love, and commitment to do vlogging and live streams, I have to do it, right? I have no choice. Aside from this, it's really my passion and my ability to give information to anybody else, social media platform and interactive virtual communication platform. Then I have to do this also, and I have to update whatever necessary for my live streams and videos also. Because the more you have so many views, and then you have also your revenues will be rising also. Okay, due to the fact I don't have so many viewers. Okay, then the only thing that I'll be able to do is to improve the number of videos that I have. Okay, so in that manner, my revenues will be slowly escalating. Okay, through that or increasing through that aspect. Okay, because I'm not really popular, I'm a celebrity or whatever. Then I have no power to capture, the feelings, or I have no power to capture the interests of those audiences out there. Okay, so going back now, again, going back to the title, acids are powerful to life, or acids are essential to life. A while ago, I already showed to you the actual basic or simple experiment by adding salt and water to produce hydrochloric acid plus sodium hydroxide, right? That is an example of getting an organic acid, inorganic acid. Okay, and now I'm showing you the organic acid. Okay, I peel the skin of the orange and I remove the juice. Okay, extract the juice here. See, so you can see, this is the orange juice. Okay, basically, this contains mainly of citric acid because orange is an example of a citrus fruit. Okay, to give an idea, majority of the citrus fruits will give vitamin C, which is what is called ascorbic acid. Okay, 6 atoms of carbon, 8 atoms of hydrogen, and 6 atoms of oxygen. Okay, I'm showing to you now how to get ascorbic acid by just mixing the juice with water. Okay, this is the juice, orange juice. Okay, I have the water in my hand. Okay, this one time check tayo ha, because I have another thing to do. Okay, this is the water, and this is the citrus fruit or the citric juice. Okay, obtained from the orange. Okay, I have to power the water. Okay, I have to power the water here. Okay, let's just expect that this orange juice have a high acidity because most of the citrus fruits have a very low acidity or the pH value, the acidity of the substance, the measure of the acidity of the substance is called the acid pH. Okay, because pH is a measure how acid or base a substance really are. Since we are dealing with acidity, we're focusing only to the below 6 pH, and that is specifically acids. And orange juice is an acid, which is a citric acid. Okay, we add water here from the citric acid or the juice. Okay, water. Any amount of water will do. It's just to represent the chemical reactions, something like that. Okay. Oh, it's there. And I will mix this properly. Mix thoroughly and properly. Okay, like this. Okay. The concentrated juice is relying or dependent mainly on the extract juice directly from the orange juice. But most of the orange juice, packed juice, and bottled juices or processed juices of orange as a main ingredient. Of course, there's a lot of fruits, right? We're considering here the orange. Of course, there is a presence of water solvent because to produce more, to have a diluted sugar with water, okay, like that, diluted, okay, meaning adding of water too much so that we can have a more production of the juice because it's not also good that direct because direct needs a lot of orange fruits, okay, so to save the cost of the company it's better to add water so that they can produce a lot of production of juices by diluting it, not the concentrated juice. That's why the market produced the packed juice, something like that. We added water to that. Of course, if there's no water, there will be no enough production, okay? Unless concentrated juices. Okay, going back. Like, oh my gosh! What's happening? So I thoroughly mixed the water with the citrus juice or the orange juice. Basically, the citric acid, right? Okay, like this. I have to taste. Mix it thoroughly because we need to mix it thoroughly so that to have a better solubility. Okay, there's a proper proportion between the solute and the solvent, something like that. Okay, so it's gonna be like that always. And then if these are chemicals that are really poisonous and toxic and hazardous, of course we cannot taste. Since this is a fruit, then there's no problem at all. Common sense. Okay, you have to taste this. There are a lot of tastes also aside from tasting. So maybe equipment and technology to do that, but not tasting already. But in this case, we have to taste because this is a fruit. No issue for health effects or whatever. Okay, so this is not chemicals. Other chemicals are harmful. Okay, so that's the key point there. Okay, I have to taste now. So I could expect a sour, a sweet and sour, something like the taste, or the tartness, a mixture of being acid and sour. Tartness, T-A-R-T, and E-S-S-S. Okay, like that. Tartness or tart. A mixture of being sour and being acidic, something like that. It's called a tartness. Perfect. Like that. Okay, I'll test. Of course, it's still sweet because the flavor of the fresh orange juice are dominant again to water. Just like happening in the salt and water, right? The dominant is the salt. Okay, usually, if we talk on the perspective, the solute taste will matters a lot also, okay? It's not the solvent, okay? But basically also there are other, products that will matter for the solvent also. It depends on the situation, the proportion. But we are using here our solvent water, so it has no taste at all. That's why our solute is the dominant taste factor of this actual simple experimentation between adding the citrus juice and water. Okay, now I'll show you the reaction in a piece of paper, the same as before. Okay, after the actual. Okay, citric acid. Anybody else? Citric acid is a formula. Okay, the citric acid by the way class is C6H8O7. Okay, like that. So 6 atoms of carbon, 8 atoms of hydrogen, and 7 atoms of oxygen. Okay, that is citric acid. Okay, like this. And the salt of citric acid is the citrate. Okay, citrate, okay, so the citrate have 6 atoms of carbon, 5 atoms of hydrogen, and 7 atoms of oxygen with a negative charge 3. Okay, let's make an acid in the citric acid, right? So adding that one, it will become 8. So C6H8O7. But we are talking only on the ATE, sorry, my tongue was furrowed. Okay, ATE, meaning citrate, chromate, phosphate. That's a technique man siya. Okay, in chemistry. ATE na word. Okay, technique man siya sa polyatomic, right? So during the clipping. Okay. My tongue was wrote, that's really an evidence that I'm not an American individual. Okay, Filipino. Okay, going back. So citric acid. Okay. Chop. Oh my gosh, why not this? Oh, kaloka. Ito pala. Sorry. Citric acid plus water. Okay, guys. Citric acid plus water. C6H8O7 plus water. Okay. When you add citric acid and water plus, it will produce an ascorbic acid. Okay, that's the vitamin C we obtained in our body. Okay, so the water are being added to produce an ascorbic acid. Since the fruit orange has already the juice, okay, there's a water already, aside from adding water. That's why we can intake the ascorbic acid for that orange. Common sense, right? It's not solid. There's a juice. The juice has a content of water for that, naturally given by God. Or else, it should not be a juice if there's the water. The natural water from the fruit. Okay, so that's citric acid. Plus water, the more will become ascorbic acid. Okay, like that. So this is again a hydrolysis reaction. My gosh, because we added water. Okay, by the way, class, since this is an organic chemistry, organic acid already, we will now call this not a hydrolysis, though the same principle. We will now call this as hydration synthesis. Hydration synthesis, meaning to say adding of water. Okay, and if removing of water, dehydration synthesis. Okay, just like I am dehydrated, meaning to say the removal of water in your body, something like that. It's just the same statement. Okay, hydration synthesis. Because there is also the reverse, dehydration synthesis. But in this part, producing ascorbic acid from the citric acid and water, it will result to ascorbic acid, something like that. Okay, and now the H2O there will neutralize to OH. Okay, because that's a hydration synthesis. Okay, like that. Oh my gosh. So, and this time it is not already a reversible reaction. Okay, it's no longer a reversible reaction, huh? Not compared to the salt and water. Reversible reaction, even though you reverse the reaction, it will still produce the original reactant, something like that. But here, it's no longer really because it's complicated organic acid, which is a citric acid, something like that. The reaction will no longer hold true in the same principle with the salt plus the water. Okay, like this. So ascorbic acid, C6, C6H8O6 plus ganun. Talaga. OH. Okay? Like this, huh? Ascorbic acid. Okay. Like this. Citric acid plus water, hydration synthesis is equal to ascorbic acid plus OH negative hydroxyl. Okay, hydroxyl, which is a component of the alcohol family. Okay, like that, alcohol family. Okay, so like this. This is the product. So this is here we can get the nutrients, vitamin C. This is the vitamin C. Okay, C6H8, vitamin C or ascorbic acid. So you have now an idea, for example, an examination, blank is a name of ascorbic acid. Your answer will be this one. Okay, okay, ascorbic acid, vitamin C. Okay, blank is a vitamin that is called an ascorbic acid. Okay, in examination, A, blah, 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 B, blah. You have to choose ascorbic acid directly. Do not be confused with the citric acid. Huh? Because sometimes other students may confuse because citric acid found naturally in the fruits and they will interpret that is the vitamin C. It is not the vitamin C. Okay, the vitamin C is the ascorbic acid as a result through hydration synthesis with this citric acid plus water. Okay, anybody, any questions so far? So that is, okay, ascorbic acid, this one, C6H8O6. Sometimes, maybe me also confused when I was in elementary, in high school education, I'm confused. I think I remember I chose also citric acid before in the NCEE, National College Entrance Examination, NCEE, something like that. Okay, in which I think I was number 10 during the overall ranking of our, in the school. As far as I could remember. Okay, so NCEE, okay, because we have to rank the most top scorers for that examination. And I'm sure I remember I was number 10, okay, for that NCEE examination. Okay, so like that. So before, in the Philippine history, the NCEE is our identification what courses we are trying to take. For example, if you are good in engineering or mathematics, then you have to get engineering course. And then your NCEE must be 80+%, 85%, blah, 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 so and so. Okay, so that's why we need to what do you call, CHAD or DEX? Before DEX, right now CHAD, right? The change. Okay, so CHAD, no, I forgot. CHAD, DEX. Okay, like the Department of Education, Culture, and Sports before, but that was not changed before, right? And CE is the measurement, what courses you will be able to take. But they have changed that now in the millennials. Okay, they changed that already. Or not change that with INSAT, okay? But in the CE before, something like that, this come up in the examination, and I tempted to answer sulfuric acid. Is another term of ascorbic acid because I don't have an idea that much before. Okay, so through studying in college and research more, I found out that this citric acid is that this ascorbic acid is the vitamin C, not the citric acid. Okay. Sure. Okay. Put that in your brain also. Okay. Like that. And I have to balance the reaction. We need also to balance. Okay. What will happen now? So carbon 6. Okay. Carbon 6. We'll start with hydrogen. Hydrogen 8. And then I put 8 here. And 8. So 7. 8. And then 1. Something like that. And then 2. So 2, 9, 10. Okay, like this. 8. And then we have plus x. Algebra, linear equation. So it's equals to x is equals to 2. Something like that. And then you have to put 2 here. And I think you have to balance the equation again, same manner. Carbon 6, hydrogen 10. And the other side is hydrogen is 10, oxygen is 7, hydrogen 2, oxygen is 8. Oh, balance, perfect. Okay, like this. I balance the chemical equation because that is really the procedure, okay, to stabilize your chemical reaction, okay? The first is to protect what type of chemical reaction, and then secondly, you have to predict what are the products if we add this certain compound or elements, and then like third is to balance the chemical equation only if you are not interested to the quantitative amount, which is the volume, the concentration, the mass. In here, we are not interested for that because we are dealing with qualitative point of view. Qualitative, meaning qualitative chemistry. We're only taking if this is ascorbic there, if the color will change to orange. It's always like that. We're not dealing with how many amounts you put there. That's why I put water, any amount. Because my purpose really is to achieve ascorbic acid only. It's not the quantitative amount. Okay? So the stoichiometric relationship has not been considered here. Okay. Any questions so far? Thank you so much for watching. Okay, Coxkey Monster. I don't know you, my friend, but I think you are my friend in college. You are one of my bloggers friends or whatever. okay, or Stingan or whatever, or my co-worker before. Thank you so much, Coxty Monster. Hi to you. I have to reply and respond. Wow. Hi to you, my friend. Ganon. Okay. Now, this is the reaction. Okay. This one, citric acid plus water will produce ascorbic acid or the vitamin C plus twice hydroxyl group, which is a charge of -1, something like that. And I balance the equation. This is the result. Okay, like that. Okay, it's very clear that when you add water, you will produce the ascorbic acid. Apart from its ascorbic acid naturally produced, if you add more water, the more ascorbic acid will be dissolved there. Something like that. Okay? Because we have also water in our systems, in our body, even though we will not drink water. Okay? The stat water, the accumulated water. Okay? So it doesn't mean that ascorbic acid will no longer be there. In fact, ascorbic acid is still there, even though you will not put water, because the juice have water itself naturally. Okay, any questions so far? I'm just illustrating and demonstrating that this is gonna be how to produce an organic acid, because I'm done in producing an organic acid. So it jives and it coincides to our title today for this live streaming is acids for life. Acids are very essential to life, something like that. Okay, now we investigate other acids. Examples. So let's go back to the simpler, components. Oh my gosh, this bundle we already put here. Finish. Okay, like that. Okay. My gosh. Investigation muna tayo. Okay, for the elemental components of any individual. Okay, something like that. Elemental components. I forgot. My gosh, too much. Okay, guys. Ganon. Talaga. Yes. Okay. Okay. Our body is composed also 75% water, okay, and a lot of fluids because of the chemical reactions or biosynthesis inside our physiological body, in the anatomy relation, brain, liver, kidney, pancreas, the gut, small intestine, large intestine, kidney, something like that. So there are chemical reactions there. Okay, so they need fluids to survive apart from the water. And this acid is also an example of a fluid. Okay, but not really the fluid enough, but still under fluid because it is a liquid substance. Okay, it matters only to their diffusion rate, how they diffuse to certain media, something like that. Okay, but the concept will be the same. If that is a fluid, that is a liquid, automatically, generally. But the fluidity matters on the media or the surface if you put that fluid in a certain media. Okay, how fluid it is. Okay, when we put that in our internal human body system, how fluid is that liquid all about? So acid is under also fluid. So all fluid are liquids, but not all liquids are fluids because there are liquids also having no fluidity at all. But that is in rare cases only. Okay, like that. So we have to investigate. Okay, the human being will survive due to the water intake, any fluid substances, any minerals, particularly the electrolytes and the salts. Okay, the vitamins from A to G. Okay, and then we have also the protein, the phospholipids, the fat, the steroid hormones, the enzymes, various types of hormones like that. Okay, basically the carbon, hydrogen, oxygen, nitrogen, sulfur, and the other minerals that we take in from the water and also from the fluid we take in also. And literally, specifically, also minerals coming from the plants also that we are taking in. Okay, not only that, but also the minerals we receive also from the GMOs. GMOs, because they carry also minerals sometimes and transmitted to our body. GMOs are genetically modified organisms. Okay, that's present also to the food. Okay, something like that. Okay, so that those food will not be attracted to the bacteria and microorganisms during the processing. Then genetic engineering will be applied there through the gene cloning, something like that, or the DNA application through protein synthesis, something like that. Okay, so that is so again carbon, hydrogen, oxygen, nitrogen, sulfur, the chons, and other minerals. Basically, in the periodic table that is under 2A, no, period 2A or family 2A, something like that. Okay? Sodium, calcium, magnesium, potassium, strontium, like that. It's in there. Okay, manganese, like this. Okay, so those are minerals. Okay, so we need that for survival. Okay, okay, and also we need acids, alcohol, and oils. All kinds of substances we need in order for us to survive. Okay, the calibrating factor there is we have to be smart and to choose the correct food and drinks we're trying to take in. That's why we need to study their health benefits and how they behave in the interactions also with other substances inside of our body through the physiological reactions from the anatomy parts of our body. Okay, something like that. Okay, going back to this acid and show you the charts now. Okay, do I talk fast? Okay, like this. Masyadong mabilis yung conversations or discussions. Just correct me. Okay, then I text to slow down the English communication. Okay, like this. Okay, tunes. Tunes. This is not a name of a person, huh? This is the acronym, something like this. And then we have to identify so that we can understand really what is its existence all about. Okay, like this. This is the tunes. Oh my gosh, time check. Because this topic actually is very lengthy. Okay, because imagine the organic chemistry can be finished in one semester. Organic chemistry 1 and organic chemistry 2 can be finished in second semester. So a matter of, let's say, 1 year, something like that. But I'm only talking for how many hours for now. I can incorporate all the necessary also to back up this information. There are a lot also to be incorporated so that we can understand very well. So what I'm trying to discuss with you now is the most important points to understand the specific topic that I'll be able to discuss with you right now. So we will start with a chance as the backbone to understand this. Acids are powerful for life. Life means for all living organisms, including the plants and the animals. Okay, something like that. Okay, number 1, carbon. Carbon is really the base in organic chemistry. In studying hydrocarbons, carbon must be the base, the backbone. That is an identification in the hydrocarbon naming. Like this is repeating over and over again in your chemistry, organic chemistry, something like that. Okay, oh my gosh. So the alkane family, okay, alkanes. ALKANE. Your identification there is the words, okay, letters A and E, and E. We need to say single bond. Okay, the carbon is bonded with single bond. Covalent bond, something like that. Okay, covalent bond, the sharing of electrons. Since the hydrogen will be attached to carbon, that is specifically referring to hydrogen bond. But it can no longer be called as a hydrogen bonding if it includes other elements such as sulfur, phosphorus, like that. So we can say that is a covalent bonding that always exists in single bond, double bond, and in a triple bond. Single bond is an alkane family, double bond is an alkene family, and triple bond is an alkyne family, YNE, okay, like that, and double bond is ENE, like that. So hydrogen and carbon attachment covalent bond. Okay, so carbon is very important. It is the basis in the organic chemistry. Okay, again, repeating to you over and over again. Hydrocarbons is a study of the combination of carbon and hydrogen atoms. But organic chemistry is a branch of science that deals with the study of carbon-based chain compound. Why I did not speak carbon and hydrogen? Because it's not limited only to carbon and hydrogen. You can also attach nitrogen, sulfur, and other chemical substances during macromolecules protein synthesis, phospholipid synthesis, nucleic acid sequencing, blah, 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 so and so, chuba, chuba, choo, choo. Okay? That's it. That's for carbon. And carbon is the backbone of carboxylic acid. Okay, carboxylic acid. Remember, if we speak carboxylic, there's a carbon there. Okay, the root word is carbon. Now, you can try to imagine, Sir Sotero, in organic chemistry, why there's no COOH? Really? Yes, it is, because that is inorganic. For example, sulfuric acid, there's no carbon there. Phosphoric acid, there's no carbon there. Hydrochloric acid, there's no carbon there, right? So chromic acid, there's no carbon there. Nitric acid, there's no carbon there, right? So it is only in organic chemistry that this carboxylic group C, double bond oxygen at the top, and single bond with hybrid OH, sorry, OH, COOH. Okay, so that is carboxylic acid. Okay, so there's a difference, right? Carboxylic acid is the organic acid, and the organic acid doesn't involve carbon atom. Okay, be careful also to that. Okay, so that's why we have hydration synthesis is the equivalent chemical reaction of the hydrolysis in the in organic chemistry I showed you a while ago, the salt and water reaction, right? And then the organic also the citric acid and the water reaction. So that is shown to you a while ago. So basically, citric acid and ascorbic acid are under organic chemistry. Okay, though the elemental components belong to inorganic chemistry, such as the carbon, hydrogen, and oxygen, right? So, but this hydrochloric acid and sulfuric acid, phosphoric acid are really purely inorganic chemistry or inorganic substances or inorganic acid. Okay, now we have inorganic acid plus organic acid is equal to acids generally. Okay, so Sotero, what else other process that we can obtain acids? There's a lot actually. If you draw their chemical formula, molecular formula, the process of polymerization reaction or any esterification reaction also, if you can remember that one, okay, we can produce acid in reversible reaction, blah, 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 so and so. A lot. If I will show you on the piece of paper and I can present to you how can we obtain other acids. Okay? H. Forget carbon. Okay, we are not in H. We're investigating the chance. Okay, H. Hydrogen. So it's a hydrogen. Okay? This hydrogen exists as a free atom. We don't put number of atoms and we don't put the number of moles beside and the subscript for this hydrogen. It's monoatomic particle for the purpose only of illustrating. Okay, like this. Okay. Hydrogen is the lightest element in the universe, discovered by Henry Cavendish. The atomic weight is 1.008 grams per mole. Okay, that's very light. Okay, so as far as I read in one of the Wikipedia, something like that, in Mars, there's a source of water there. Okay, but the problem is the hydrogen is converted to deuterium, okay, like that, and exists as an isotopic substance. That's why it is being, absorbed in the Earth's crust. No, not Earth, because it's Mars. In the Mars crust, something like that, and then the water level becoming low. That's why nobody can survive there anymore. But in the study before, that Mars, life is possible because there's a presence of water. But due to this, conversion reaction, the hydrogen, a free atom, it produces a deuterium and tritium, okay, isotopes, okay, meaning elements that have the same atomic number, or let us say the number of atoms or the number of protons are the same. Again, elements that have the same number of protons or atoms but differ in their mass numbers. Okay, those are isotopes. So it undergoes an isotopic chemical reaction. That's why the behavior of being a water was being completely deteriorated and it's being interrupted. It will not function anymore as a regular and natural water. It goes and deposited to the Mars crust or soil ground, something like that, and then water is being minimized and lowered, and then no life is possible there in Mars planet. NARS. Okay, that is hydrogen. So hydrogen exists in three pala. Okay, H is a monoatomic, diatomic, and triatomic. Monoatomic is what we're using now in the chemical reactions, photosynthesis, blah, 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 chemical synthesis, chemical reaction, whatever, okay, but this deuterium and tritium used in the other chemical reactions, I think particularly this in the nuclear chemistry, okay, in nuclear power plant, they employed this. I think this is part of fission, fission chemical reaction, the conversion of hydrogen into a heavy molecular hydrogen somewhere in the chemical reaction, nuclear chemistry, okay? It's be used, the two isotopes of this hydrogen, deuterium and tritium. But going back to hydrogen alone, okay, because Henry Cavendish did not discover the tritium and the deuterium. He discovered only the hydrogen exists as a monoatomic particle or atom, something like that, this hydrogen. Okay. This hydrogen can be added to polyatomic to produce an acid, an inorganic acid. Okay, I already discussed that 3 months ago, 4 months ago, something like that. So this is having a charge of positive. Okay, when we speak about positive, the charge, okay, of this hydrogen, we mean this is a proton. Okay. Proton, something like that. So the hydrogen will donate the proton to that polyatomic anion because an ion is a negatively charged particle or negatively charged compound or particle alone. It depends on your concept as long as you have the basic foundation of theory and principle. Okay, electrically charged an ion or electron, something like that. So, hydrogen. So, an example kasi yung siya. Okay, we have the HCl, hydrogen plus proton, plus chloride negative, an ion, then clip it together, it will become a hydrochloric acid. So, this H will love to donate the proton to the chloride and ion, and then they will form a compound that is neutral already, no charged. Okay, with the compound acting as one from the polyatomic ion and from the H positive, there's no charge at all unless you will break that in a chemical reaction. Okay, so it will become neutral when they clipped and combined with each other. Okay, this is also sometimes the confusion of some chemistry students because they don't distinguish what is a neutral particle, what is a neutral compound, something like that. Okay, we will break that one. It will produce these charges. The negative from chlorine, it will become a chloride. Okay, and the positive with hydrogen ion. Okay, ion meaning it could be a positive particle, it could be a negative particle, regardless of the charge. If it is positive or negative, that is the definition of ion. Okay, positively or negatively charged particles are called ion. Ion. That's why we have ionization reaction. Okay, reaction involves different types or different forms of ions, something like this. Okay, this hydrogen, very essential also in acids, in producing organic acids. In the reaction also, related to carboxylic acid, which is COOH. Grabe naman. Very talkative si June. Okay? Hydrogen. Okay? So, that's why we have that one. Okay, so hydrogen. So it could be attached directly to chloride to form hydrochloric acid. And so we have the digestion acid inside our body. Okay, like that. Another is sulfuric acid. Okay, sulfuric acid can be obtained also from our body basically, but not all the time. It depends upon on the intake of the food we have, especially if the food and drinks we take in contains traces and amounts of sulfur content. Okay, since I can investigate what levels of sulfur content that I can be able to discuss to you right now because it depends. This is not a laboratory that will be able to show you the content of the sulfur when you take that from, for example, a potato. I'm not really sure a potato have a traces of sulfur. Correct me if I'm wrong. Okay, like that. Then I cannot say exactly and specifically the amount of traces of sulfur that present in the potato. What I am trying to say that if we take in the sulfur inside our body, then it will produce sulfuric acid through the reaction of the sulfates. Okay, sulfates, the salts plus the water. We have the water inside our body, and we have the sulfates, right? Of course, we have oxygen. Remember, okay. So sulfates plus water, they produce sulfuric acid plus hydroxyl group. I speak only hydroxyl group because we don't know what salt will try to react with that sulfuric acid, or will try to react with that sulfate because there's a lot of salts, right? We have a sodium, magnesium, blah, 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 okay, calcium, blah, blah, blah. So I cannot predict exactly what salts they're trying to attach during the product. Okay, but I'm trying to explain that sulfuric acid can be produced through the chemical reactions. Sulfate plus water will produce sulfuric acid plus OH or hydroxyl group, something like that. Okay, because of the food and drinks that contains traces or amounts of sulfur. Okay, so we can obtain sulfuric acid. Okay, hydrochloric acid, sulfuric acid, now phosphoric acid. Okay, this is inorganic. I'm showing only an investigate to the chance because it reflects to my title. Okay, acids are essential for life, right? Then the only way to connect that is to explain properly. Okay, how they behave, how they react, what are their beneficial uses, of course, right? Okay, going to phosphoric acid. Okay, oh, Sotero, phosphoric acid, really? Yes, you can produce that. Okay, because we take in phosphates also in our body. In what situation, in what situation, Sir Sotero, if we can produce phosphates? We can produce phosphates through adenosine triphosphate, the main source of energy. Remember that one in the photosynthesis, in the photophosphorylation reaction, okay, light-dependent reactions by the heat of the sun through photosynthesis. We can also produce the triphosphate for that, coming from the chlorophyll, okay, with the reaction of oxygen, something like that. So adenosine triphosphate, imagine there are 3 phosphates there, okay, and that is our main source of energy. Okay, this adenosine triphosphate will be converted into several of glucose, 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Imagine if we introduce phosphates for that, for our energy. We take now in our system, normally we produce phosphoric acid in our excretory system or inside our system. Okay, so that's very clear. And not only that, you keep on adding phosphates also when you drink Coca-Cola, soft drink, okay, something like that. Okay, yes. Because Coca-Cola, I worked in Coca-Cola Tagbilaran before in 2000, okay, as a product, chemical engineer, something like that. Okay, so we have a raw material for that also, a diluted phosphoric acid found in a Coca-Cola soft drinks. Okay, so that diluted phosphoric acid also will add to your system. So many phosphate you have now. That's why the liver cannot function properly in getting rid of the toxins coming from these phosphates also, and it will deposit to your kidney. Okay, because this is a salt. Not all salts will be washed away by the water. Others will be penetrating there, especially we are not drinking too much water. Okay, so that's why you have to drink water 8 to 10 glasses every day for good digestion and to dissolve our acidity of various substances that will take in our body, something like that. So it causes kidney failure. First, it will become a UTI, urinary tract infection, and then produces salts. The salts there become a stone, a lot of salts, not only the phosphates. Okay, there's purine, uric acid, chromates, oxalates, something like that. Calcium salts, magnesium salts, a lot of salts will be there. A group of salts will be happy together, existing and accumulating in your kidney. Something they're enjoying there. Okay, a lot of groups. Okay, let's create fraternity, something like that inside our kidney, and they are enjoying there. Okay, they're singing, dancing like that, and penetrating and accumulating to your kidney and become a stone. Then, if you don't do something, it will create a big inflammation of your kidney, and then it will become a kidney malfunction, and then you need dialysis. Okay, for the and it's very costly for the medicines for the maintenance of the kidney failure. Okay, remember. Okay, I'm only illustrating to you the phosphates. Okay, through phosphoric acid. Okay, a lot, right? Not only that, we can also get that through acetyl CoA, who are biology students. Acetyl CoA, right? Remember that one that is a molecule in chemical reactions that participated in the lipid and carbohydrate metabolism, right? Then it will use the acetic acid or something like that, okay? Acetyl group, and then it will be delivered to the citric acid, and after that, it will be oxidized to produce an energy, something like that, okay? Do I have to illustrate the formula of acetyl CoA? Oh my gosh. It contains, really, I really researched and studied more also, that's why. Before I'm talking to you, I studied more, the only studied more, researched more, read more, something like that in relation to my course as a chemical engineer. It's easy for me to relate because that's chemicals, right? Okay, what is missing only in the bio part, biology, because we're not dealing with biology in chemical engineering. Okay, so that's why I'm interested the most regarding biochemistry and biochemical engineering, because it talks about human survival, right? Health science, medical science, that's why it interests me the most. Okay, when I was in my 30s, I'm interested in that one. Now I'm in my 40s. Okay, I have to be interested for that. Okay, 10 years more, 20 years more, then I will become old. Okay, the collagen will decline. Okay, if I have no collagen, I will become weak. I cannot survive, and that's the time chronic diseases will come in. At least I am very proactive to determine those pathogenic substances that want to destroy my immune system. Okay, without money involves, right? Because it's proactive. No money involves. Because if you are just knowing that in your 50s, in your 60s, then you have to go to the doctor all the time. Okay, because you don't have an idea and what to treat. Okay, and you don't know an idea what to prevent, what to avoid. Tell me you will always be dependent to others to tell you something. No, it's not. It's not practical to do that. You don't have so many friends to tell you everything about health benefits because they are not enjoying also science. Okay, they're enjoying laughing, joking, going to the outing, exploring to other countries. They will never see that. Okay. Understand? So only a vlogger and a YouTube content creator also can specifically state that for you, though not all the time, but I think this is the right avenue for that. Okay, health science, sciences to human survival. Time check. Okay. Diba yan, June? Time check is 2 o'clock in the afternoon. 96.3 W Rock. Ganon. Okay. Tapos tayo dyan. Oxygen! Sotero. Kasi saan na discovered sa oxygen? It was Jules Presley. Okay, discovered oxygen. And oxygen is the most abundant element in the Earth's crust or in the planet Earth. Okay, so maybe it will come out also in the examination. Don't be confused with the other one, Blanc is the most abundant organic compound in the planet Earth, that is cellulose. Okay, let's be confused. Sometimes also will be confused. So some will answer oxygen for that, but oxygen is not a compound, right? So you will answer cellulose. Okay, because remember, cellulose can be produced, okay, 100 billion tons per year. Okay, cellulose is a polysaccharide sugar. Okay, very useful in different food industry, something like that. Okay, so the answer will be oxygen. If it is the most abundant element in the planet Earth, because the most abundant organic compound in the planet Earth, it is the cellulose. Okay, this is science. Okay, maybe it will come out of the examination. Okay, number 4 is that oxygen. I'll discuss more about oxygen. Oxygen is very reactive. Okay, oxygen is very reactive to any elements. Okay, that's why we have combustion reaction, redox, okay, reduction, oxidation reaction, the loss of electrons. If it is losing the electrons, and then it is producing an oxidation reaction, and then the substance is being reduced. Reduced, correct me if I'm wrong. No, oxidized. See, it's really very difficult sometimes for quick vlogging, right? So you have to think quickly. No, why reduced? I'm talking about oxygen, right? So oxidized, because oxygen is oxidation. See, like that. But it is a reducing agent. Okay, like that. So even me, even up to now, right? I'm really confused for that also when I was in college also, because loss of electrons, gain of electrons, something like that. It will be oxidized, it will be reduced, and then you will call that as a reducing agent, okay? And it's reversed. Again, if the process or chemical reaction loses electrons, that is oxidation. Now, the substance is being oxidized. Now, that substance, it is a reducing agent. Okay, so that's a little bit confusing. Okay, and then the other one, which is the gaining of electrons, the reduction, gain of electrons in the chemical reaction. Okay, so normally the substance is being reduced, but it is used as an oxidizing agent. Okay, so this is sometimes very confusing. Okay, but we need to understand that slowly through the chemical reactions, how it behaves. This is the only way to understand further, is to really illustrate the chemical structural formula and try to react with others so that we can really, that's why it's become a reducing agent, because it's function to make that reduce, something like that. Because if you're only memorizing that one, then we will be lost. Something like that, okay? Because, we trust our memory, and then our comprehension ability is not too high, then analysis will be wrong, something like that. Sometimes, though, memorization is very important also in passing examinations, but we have to understand really, we have to analyze, it's going to be like this, and we have to investigate, scrutinize all, something like that, so that we can understand properly, right? Okay, so that's oxygen. Okay, this is also helpful in the photosynthesis, okay, the production of adenosine triphosphate, also useful in the glycolysis reaction, my friend. Wow. Glycolysis talaga. Okay, glycolysis in metabolism, that is producing a lot of glucose, or the breakdown of glucoses from glycogen. Okay, because glycogen is a storage of glucose, and it will be break down through the process of glycolysis to produce several glucoses that will be used in our liver, hepatic glucose, right? And also the blood, which is the blood glucose, or the glucose from the blood, or blood sugar. Okay, so that's necessary, the glycolysis reaction in our body. And that's what we call that as a aerobic process, cellular respiration through glycolysis reaction. May ganun talaga. Okay? Oxygen, photosynthesis, and also the combustion reaction. Okay? So, in short, we cannot survive without oxygen. We will die on. Okay. Number 4, nitrogen. Oh, by the way, I'm going back to oxygen. Oxygen, 21% in the atmosphere, like that, the standard, but it becomes lower because of the pollution, because of the air pollutants and airborne contaminants existing in the atmosphere. Okay, so it's becoming like that. it's below 21%, but I'm talking to the ideal 21% of oxygen given by God. Okay. Number 4, nitrogen. Nitrogen. Okay. So the example of gases, acid and oxygen, there's a lot, of course. All acids having oxygen content. There's no excuse for this, sorry. So all inorganic acids and organic acids composed of oxygen in their molecular formula alone. So we don't have to specify what example, blah, 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 so and so. Because all of them have oxygen atoms, okay? All of them. There's no excuse from the carboxylic group, okay? Like there's oxygen from the organic chemistry, something like that. The inorganic chemistry sometimes added also with water. Okay, there's an oxygen always. Okay, it will become an acid really if there's a water, and water have oxygen, right? And so oxygen is very participatory. Okay, all the time, very reactive, right? Participatory or very reactive. That's why it produces an acid, right? Okay, nitrogen. Sotero, we have acid produced by the nitrogen. Of course, we have. Take note of your urine. Okay, your urine have uric acid. Okay. Uric acid has nitrogen atom. Remember that one, okay? When you take your urine, investigate that one, the color is yellowish, something like that. When you go to the toilet, and there's a presence of nitrogen, something like that, through uric acid. So what is the formula of uric acid? Okay, 5 atoms of carbon, 4 atoms of hydrogen, 4 atoms of nitrogen, and 3 atoms of oxygen. So it's very obvious that there's nitrogen there. Okay, like that. Since the basis for that are the purine. You know purine? You know purine? P-U-R-I-N-E. This is the basis for citric acid. Why purine will be produced? So it will be oxidized from uric acid. This is what I throw an example to you, right? Oxidized to purine, and this purine is the dangerous one. Okay, it's not the acid; it's the purine in the uric acid is the dangerous one that can cause the common known arthritis, right? Caused by the excess level of uric acid in the bloodstream, something like that. Excess overconsumption of the foods and drinks that contains mostly of purine. This purine comes from uric acid, basically. It's not really that uric acid, it's the purine. Because without this purine, that is not danger. Okay, like that. The purine is 5 atoms of carbon, okay, something like that, 4 atoms of hydrogen, and 4 atoms of nitrogen. So there's no O. So that means it will be produced during the oxidation process, something like that, blah, 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 so and so. Okay, I will show you the reaction later, huh? And then for that alone, we can say that the symptoms are due to white crystalline substance. Sir, what's happening with crystalline substances? So these are the purine, okay, like that. Because acid is not a solid, of course. Imagine common sense, okay? Uric acid is a liquid in nature. So the solid there is the purine, okay, the white crystalline solid substances that were exist and accumulated in the joint, in the base of your tooth, this one too, okay, tooth, and this is, the disease is known as gout, G-O-U-T, gout, okay, this is a common known arthritis, sorry, like that. So what are the causes for this, Sir Sotero? Okay, the causes for this are drinking too much alcoholic beverages. Okay, because it is studied due to experimentation, like blah, 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 that beer contains more purine. Okay, which is the basis for uric acid, and due to chemical reactions, it will go to your liver. And your liver cannot filter that anymore, something like that, and it will be deposited also to your kidney, something like that. Okay, so that's a problem. Okay, gout will really exist for that. Okay, because this is the waste found in the blood. Okay, because normally our body creates this purine through the breakdown of the chemical substances in our body. That's the uric acid, what I'm telling you, right? Uric acid to purine, something like that. Breakdown. Okay, gibungkag niya to produce purine, and this purine is the dangerous one. So if we eat too much meat, bacon, okay, like that, the meat of the deer, like that, okay, the battered food, okay, the dairy products, the oily sardines, tuna, and the oily, all about oily, liver, chicken, okay? So those are the causes of the gout to be visible in your system because you will feel it. That's why, right? You will feel it. Of course, you can really feel that there's a purine or uric acid too much in your body, even though there is no medical results to prove for that. Okay, because it's in the tube, blah blah blah, like that. So it's a form of arthritis. Okay, something like that. Okay, so that is the uric acid and the purine. So of course, that contains nitrogen. Okay, so after nitrogen, we investigate the sulfur. Okay, why the sulfur all about? If this sulfur will come in, the phosphorus also will come in. Yes, really, they love to band with each other also, especially in the sulfhydryl functional function, right? Really, they will follow with each other also. Really, okay? Sulfhydryl reaction, you know that one? The combination of sulfur to hydrogen and to alkyl, something blah blah blah. Okay, this sulfur. For example, the acetyl CoA also is a large molecule also. Okay, contains also sulfur, really. Okay, and the adenosine triphosphate also. Okay, try to discover that one, okay, something like that. Okay, so there's a sulfur there. Maybe the sulfur in the adenosine triphosphate will be oxidized. It will be no longer present there through some, this dehydration synthesis and on. Okay, so you can see there. That's what I'm telling you. If we do show the chemical reactions, then we cannot understand clearly if there is sulfur, if there's no sulfur, or something like that. Okay, this is the tunes. The tunes are very important to produce organic acids and inorganic acid. Okay. And now, we'll go to the examples. Oh my gosh. I love to present first the organic acid because it's more interesting, right? The organic acid. Okay. Very interesting compared to the inorganic because we are used to for inorganic acid really in our chemistry, right? Okay, but the other one, the organic acids, is very interesting also. Okay. And let me show you that some examples. Okay, ganyan, blah, blah, blah. Okay. Okay. And I need to state the examples, yung related sa atin po first. Pinaka-related, something like that. The first acid that I will be able to introduce now, benzoic acid. Naman, benzoic acid first. A lot of acids kaya, maubos yung oras. Check the time. Benzoic acid. So, Sotero, benzoic acid, meron ba ganun? Yes, it's come from the benzene. Okay? Like this. Okay? Wait, check. Okay. Maganda sa oras, in fairness. Benzoic acid. Okay, first, technique and quick identification. We can produce acid, right, from the hydrolysis, okay, from the salt and water. We can also produce that in organic chemistry through esterification reaction, okay, from reacting water to esters, okay, and we'll produce an acid, okay. Ano ba yan? Anong ester? Ester is equal to alkyl, capital R, banded to the carbon, capital R, banded to the oxygen, banded to the carbon, double band oxygen, and single band H. So ROCOH. So the carboxyl group is in there. You have only to add OR in the right corner. So this is ester. So that's why we will say blanc is an acid produced in esterification of the water of this particular salt. And we can have an acid immediately because we determine the kind of ester. Okay, that is for organic. Okay, blanc is the esters found in the reacting with water to produce this kind of acid. And the other inorganic also is not the ester. We will say blank is the salt that can be produced by blah 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 and acid to water, something like that. Okay, salt and water to produce this acid. So it is the salt is the basis in organic, because we can no longer say that ester is a salt in an organic point of view. But this is an equal analogy or understanding that we use ester as a salt to drive the principle behind hydrolysis to organic chemistry, which we refer to that as hydration synthesis. Okay, like that. Okay, and to give you an example for that, benzoic acid. Okay. Benzoic acid, so that's acid, right? Then you have to add the OH. Sotero OH? Yes, OH. Why? Because it's an alcohol. Okay. Wow. Benzoic. Saan mo na kung benzoic? Benzoic ko siya. Wow. C6H5COONA. This is the benzoic acid. Oh my gosh. Kaloka. Okay. This is benzoic acid. Hala. Ganon. Benzoic acid. Okay. Now, it is an acid. I will show to you why it becomes like this. A carboxylic acid is this. Charot, okay? Ganon. This one, oxygen. Charot. And then H like this. Then R. Ganon. Okay. Then the R. So, C6H5CO, okay, ganon, and then attach to this, okay, like that, okay, so, like that, okay, this is carboxylic acid, right? Carbonyl, actually this is carbonyl group, this one, carbonyl group. But carbonyl, it doesn't specific to acid only. That's why you cannot apply it every time. Carbonyl group can be applied to ketone, to aldehyde. So though it is still carbonyl group to be called for, but since this is carboxylic acid, we will just use carboxylic acid specifically. Okay, though it is also carbonyl group, huh? Because I'm telling you, it's okay to say carbonyl group for this. Okay, so carbon double bond oxygen, OH, and this is the alcohol there. Alcohol represented OH, alcohol. Okay, and this is the R. Our R here is this one. It's the benzene. Okay, this one. Actually, it's coming from benzene. Okay, the one atom of hydrogen was being donated to the sodium. Okay, as I told you before, the benzene, 6 atoms of hydrogen, 6 atoms of carbon. And then the 1 atom of hydrogen was shared to this. That's why it becomes C6H5 only, because it's being, shared to Na, sodium. Okay? Like this. That's why this is the formula. Actually, it is taken from benzene, C6H6. Okay? Our bases. Okay? Like this. Benzene, C6H6, and then since we have hydrogen here, okay, there's a positive one here, and then still the other hydrogen one, still not sharing, sharing. Okay, this sodium will get the 1H from there, and it will become C6H5. And COO, so Sir Sotero, what's the COO? No, that would not matter because that's only the general formula of COO. Okay. That's not a part of the sharing there. Okay, only this part here. Okay, so the R here will be the C6H5 with Na. C6H5 with Na. Okay, something like that. Will be in the R, something like that. And this is the alcohol. Okay, like that. So we can say that this alcohol will be produced by the reaction of this esters and water. Okay? Like that. So, esters ang anuhin natin kasi po, ano ito? Organic chemistry. Wow. Okay? Klaro na siya, benzoic acid. Okay? Oh. Benzoic acid. But we don't need to take in the benzoic acid because it's poisonous, ha? It can only be produced during the chemical reactions or biochemical reactions inside our body. In what way? Okay, if we drink too much soda, soft drinks, okay, soft drinks, Coca-Cola, Pepsi, like that, okay, this will produce benzoic acid already in our system, already in the inside, not on the outside, because if you drink benzoic acid in the system, we will poison. It's not the chemical benzoic acid, it's the benzoic acid that will produce after the reaction inside our body. And that is, I want to show how it works inside our body. I have to discuss. Okay, if I drink soft drinks, I don't have soft drinks here. Okay, oh, I have soft drinks. If you check the nutritional fact, there is a sodium benzoate. Okay, as I told you a while ago, if it ends in ATE, that is a salt. Okay, or ester in organic chemistry. ATE in organic chemistry, that is a salt. Organic chemistry, that is an ester. Now, if that benzoate, let's say here, this is a sodium benzoate, okay, like that. Okay, like that. Sodium benzoate, okay. Grabe naman ito, talaga. Lumalalim. So, ang sodium benzoate, ito siya ha. Anybody? Sodium benzoate? This one. Sodium benzoate. Okay. Sodium benzoate is an organic ester, equivalent to the inorganic salt. Okay. Then, in organic chemistry, we will be able to show the hydration synthesis here. Okay. To produce the benzoic acid that we are trying to explain because of our title, acids are essential to life, like the bubble and so. Okay, so let's do the reactions now. Okay, sodium benzoate. By the way, the sodium benzoate found in a carbonated drinks. When we speak about carbonated drinks, that is mainly involved of a lot of carbon atoms and a lot of preservative. Okay. This sodium benzoate is a preservative, okay? It is a food pickling agent that we try to preserve and extend the shelf life of the product for 6 months, 1 year, 2 years. That's why this preservative is very bad to the health, okay? So this sodium benzoate is a preservative that will try to preserve, from the word preservative, it's hard to preserve and extend the duration and the life of this product for at least 6 months, 1 year, and 2 years. So that is very dangerous to have. Okay? I'll show you. The sodium benzoate is a preservative. Okay? Now, okay, I'll show you the example. Okay, since most of the soft drinks have this one, I think I'm not really that. I'm not educating, or I'm not sponsoring the Coca-Cola. Okay, because I worked before at Coca-Cola. I'm not saying like that. I'm just saying the truth. In Coca-Cola, because I've worked there before, they remove the sodium benzoate. Sorry. Okay, I'm not telling you the Pepsi or the other soda drinks. This is only for Coca-Cola because I've worked there. Okay, they remove the sodium benzoate in their diet Pepsi. Oh no, sorry, Diet Coke because it is dangerous to the health. Before, they incorporate the sodium benzoate in the Coca-Cola diet. Okay, but now they remove it. Okay, like that. Though they also put that in other soft drinks, but in sure 100%, they remove their in the Coke diet. Okay, the presence of this preservative, the sodium benzoate. Okay, but other soft drinks have this as a preservative. Okay, check the nutritional facts for that. Okay? Now I show you the reaction. And then later we'll be able to discuss what are the negative health effects for this preservative sodium benzoate and what is the health benefit for this sodium Sodium benzoate. Because if there are positive health effects, we have also negative health effects. Of course, there will be a balance in everything. Okay, unless it is a pathogen substances that there's no health effect. It's always really a substances that causing a disease. That's pathogens. But most of the substances are not pathogens. Okay, they are really good at quite sometimes or other nutrients or vitamins, but they have only side effects. Okay, like that there are other negative effects, but not really that bad at all. Only for overconsumption, like overdosage, too much intake, that will become a problem. But if you try the natural way of doing it or drinking or whatever, then you cannot cause like that. Okay, something that I'm just showing to you that this sodium benzoate, a preservative incorporated in all carbonated drinks except for the Diet Coke. Okay, like that, it's dangerous to our health. Something that I'll show you the reaction how it behaves. Okay, like that. So ester. So, okay, this is sodium benzoate. So you can see already, sodium benzoate is the salt from benzoic acid. You consider it like that also. Okay, so because it's coming from the benzoic acid, if you try to reverse the chemical reaction, okay, so it's reversible reaction para siya. Okay, it goes back to its original reactant after several chemical reactions. Okay, it's reversible reaction, something like that. Okay, sodium benzoate. Okay. My God! Imagine I'm trying to. There's a lot of acids, but the time is already 1 hour and 16 minutes. Imagine. This is a very lengthy discussion, right? Sodium benzoate. Okay. Actually, makabuang siya if you try to, dig something, especially for for the microorganisms, how they behave and catch the sodium benzoate. Actually, it's really a headache. Sometimes when I read the book and I read, in the Wikipedia something, my brain is, getting tired sometimes. Oh my gosh, too much. The terms, the behavior, the chemical reaction, how you'll be able to, to troubleshoot their, exact component and composition in a chemical reaction. So, ano lang, tama lang. Charot! Because makabuang siya. Okay, really. Okay, sodium benzoic acid. Wala ko eh. Anak, Jude. Wow. O, di ba? Ganun siya. Maorgan siya sa neutralization reaction between acid and a base that produces salt and water. Organic chemistry is just the same. Only that you employ the esterification process. Okay? Instead of an acid alone, the organic chemistry referring to the carboxylic acid or the saturated fatty acids or the unsaturated fatty acids. That's only the difference for the terminology, but the same concept behind for that. Okay? Like this, okay? Sodium benzoate, which is a preservative found in carbonated soft drinks, plus water, is equals to benzoic acid plus sodium hydroxide. Okay? Always using sodium hydroxide, okay? Yes, because we have salt in our body. Okay? So sodium will always attached. Okay? Pakialamira itong sodium na ito. Okay? Because you always attach to other acids, something like that. Okay, in sodium chloride like this, and then you also go in the benzoic acid. See how active the sodium also, because this is a salt that's an electrolyte. Okay, it will really adapt the electrons from other, especially the hydroxyl, right? The electrons in the hydroxyl, the OH, right? So you will be bound there all the time, something like that. Okay, so he is very hungry all the time and thirsty to be banded with this hydroxyl group, especially the alcohols. Really, okay. So it's gonna be like that. So we need to illustrate now the molecular formula, okay, so that we can understand how to balance it. It doesn't mean that in organic chemistry you will no longer balance the chemical reaction. You have still to balance that one, okay, to achieve a perfect reaction somewhere along the way. Okay, something like that. C6H5. My goodness. Okay. Plus water is equals to benzoic acid. Okay? Klaro ha? So, just focus on the concept and principle behind, because whatever organic compounds you will be able to attach, you can understand clearly. Okay, so focus on the basic principles behind. Okay, discussion. Okay, like this. Plus sodium hydroxide. Okay, like this. And the water, it's not necessarily mandatory. You need to intake the water just to achieve the benzoic acid. As a product, it doesn't mean because we have water accumulated in our system. Dili alatul, we drink moya. Okay, water, pani. Pani, moya, we drink every time. So no need to add too much water upon producing the benzoic acid. Okay, because we drink soft drinks. And this is the process really if we drink soft drinks. It works inside our body when you drink soft drinks. Okay, like that. So we need to balance the equation, Okay. Oh my gosh, too much. Carbon 6. Okay, and the other side, carbon is. I'll not show you later, I'll show you. Okay. 6. Oh my god, too much hydrogen. Oh my gosh. Really? Too much hydrogen. 6. Ganon. Okay, sodium 1, sodium 1 also. Okay, dami naman. Okay, oxygen 2 plus, oh my gosh, 3. The oxygen here will be, 3 na agad furnace. Okay. And for the hydrogen 5, hydrogen is 7. The hydrogen here is 5, 6, 7, right? Natakot ako. Wow! Talaga. Yes. Oh my God! Perfect reaction. Oh guys, come on! Listen! For the benzoic acid chemical reaction from sodium benzoate, which is the preservative found in soft drinks, plus water inside your body, okay, will produce benzoic acid plus sodium hydroxide. Okay, we wonder why we have sodium hydroxide in our body. Yeah, really true. We have. That's why we have salts. Okay, like that. Okay, now perfect. Balance already. We don't do anything. Okay, there are situations like that also. We need to present the chemical reaction. After presenting that one, it's already balanced all. Okay, meaning to say perfect and ideal chemical reactions. We don't need to balance too much. It's always balanced all the time. So meaning to say my equation is perfect, is correct, something like that. Okay, or else if it doesn't balance, there's something wrong with my carbon, hydrogen, oxygen. And at that time I will try to to balance it more. Okay, so this balance. Okay, now, okay, so this is a flavoring. Flavoring material, flavoring. If we see flavoring, it starts with capital E. Take note that in the carbonated sugars, carbonated soft drinks, there's a capital E. We have E112, E114, E110, and this E110, something like that. So I think so. This preservative known as sodium benzoate is E112. This means the colored material, coloring food material, something like that. Okay, right? The soft drinks have many color, orange, red. So this is a coloring material added to it. This will become E, something like capital E. Okay, like that. Notice that one also. We have also the capital E110, which is the sunset yellow, something like that. Okay, the coloring material, the preservative, the sodium benzoate. Okay, and now what is the negative effects? And have effects if too much sodium benzoate will be inside our body. Okay. So number one, first we need to have the symptoms first. We will feel overconsumption. I'm talking to overconsumption. I'm not talking to normal only eating, drinking of soft drinks. I'm studying. Most of the times you drink like this, blah blah blah. Okay, overconsumption. What I mean. Okay, so this is vomiting, nausea. Okay, abdominal pain in your stomach, abdominal pain, and then it will result also to chromosomal damage in your genes, chromosomes. Be careful. So if your genes and chromosomes will be damaged, so there's also affecting your reproductive system. So it's also have a potential that you are not productive anymore. For example, you cannot have a children too much because of this causes also preservative. Okay, because chromosome damage, right? There are persons that cannot bear too much children or cannot yield children because that's also based on the food what they eat, and there are also that can damage the reproductive organ, the genes. To take note, the sodium benzoate have chromosomal damage. Chromosomes, remember, 23 chromosomes plus 23 chromosomes like that, it will be damaged. Then there's a chance that if you married, you cannot produce a child, something like that. Okay, if you're always drinking soft drinks. Okay, this is new, right? Because it's only rare cases also. And then I think it will be happening if it is overconsumption. Or you will never do the exercise and then you have an imbalanced diet. Of course, this sodium benzoate will function as a bad, okay? Because chromosomal damage. And not only that, kidney tumors will be developed through excessive drinking of soft drinks due to this preservative known as sodium benzoate. Be careful, okay? Because carbonated drinks have sodium benzoate, which is a preservative, okay? Like that. So that's the symptoms. And the tumors of the kidney and the chromosomal damage or the effect. Okay, overconsumption or in the future, something like that for a long period of time, take it a while. Okay, and then it is also trying to deplete to eliminate some energy function enzymes or the amino acid. Okay, for example, the carnitine. Ang lalim. Carnitine will be depleted in your system. This carnitine is a very, very, very important amino acid that play an important role for energy production, something like that. Energy production meaning you are active, you are very strong because this carnitine, this is its function to produce an energy. And if you keep on drinking soft drinks, there's a time you'll be fatigued, something like that. If you feel that, but also an example for that is your abdominal pain and you keep on urinating and your stomach will be painful like that. So that's really a sign already, right? That there's a depletion of this carnitine, not to function as an energy producer, okay? Because it will be depleted or destroyed by this sodium benzoate. Okay, like that. So, example, this carnitine, okay, basically composed of various fatty acids that will be transported to the mitochondria. Wow, lalim naman. Mitochondria, and then it will be oxidized and burned there to produce an energy. Okay, so if that is the case, we need to remember the reaction of oxidation and reduction. How this carnitine will be oxidized to produce an energy, because this is the main function of the carnitine amino acid. Okay, like that. Okay, so this is very important to all energy drinks and weight loss energy drinks also. The inputted and fortified with L-carnitine amino acid for slimming. Okay, you will become thinner, lost weight during exercise. Okay, L-carnitine, something like, basically the L there is due to oxidation. Okay, it produced like this. Actually, there are a lot alpha, beta, And so it depends on the chemical reaction. L-carnitine was used there. Okay? So fit and right. FITNRI. Fit and right is an energy drink. Okay. The formulation of fit and right, they introduced the carnitine amino acid, okay, to keep those people drinking that one to help regulate their energy production well. If the energy production well regulated, there's a chance that there must be a weight loss because this carnitine is very important as an amino acid in our body. They are very wise. That company producing Fit and Right, they always have, not always have, they incorporated already the amino acid called carnitine in their Fit and Right drink because of that purpose. Okay, the fatty acids will be oxidized there to produce an energy because this is a very, very vital amino acid. And this will be destroyed by drinking soft drinks because it contains sodium benzoate as a preservative. So this is the disadvantages and negative health effects of drinking too much soft drinks because of the preservative sodium benzoate, aside from the symptoms I discussed a while ago. Okay, but take note, there is also one positive health impact for the sodium benzoate as a preservative. This is to inhibit the microbial growth, okay, and then effective to fight against bacteria and antifungal. See, as I told you before, there's a health negative effects and there's a negative effects. So the only way to do that is to balance your intake of drinks and food in your body. Because you know already the reaction I show you in the piece of paper, right? How it works. I relate that here to chemical reactions. Right? So it's gonna be like that. Okay, you have to identify the behavior, how it behaves inside your body. Okay, like so, it's gonna be the benzoic acid. So bingo, we're finished now the benzoic acid. Okay, let's go to another acid. Gosh, dami yung acid ito. Now let's go to butylic acid. Hala, ang lalim na butylic acid talaga, sir. Wow. Yes. Ang oras na, uy. Ano ka? Butyric. Uy, mag-insert pa ng butyric ha. Ako sa niyan. I'll able to stop this for a while. So that's very lengthy already. 1 hour and 32 minutes. Alright, thank you so much. Ang dami na nanood sa akin. Wow. Talaga. Yes, thank you so much. Oo. Diba? Nag-chat sila sa gilid-gilid. Oh my gosh. Yes. Talaga? Oh. Okay. Hello, Sir Kotsky Monster. You have to study more on the backbone, which is the pure sciences. Okay. If you have already the master's degree in nursing, all you have to do also to intensify your knowledge regarding science because you can always back up your nursing job with the latest updates of any proven scientific research or scientific technology that could also be helpful to make your job easier, something like that. Okay, we need to enjoy the profession that God had given to us with the support of our family, of course, because we take that course for us. All we have to do is to develop that one and enhance that one in combination to the latest and newest technology around you, okay, with some knowledge regarding pure sciences, because I know also nursing have chemistry, biochemistry, but I think so you have also to upgrade with that application of technology, something like that, because nursing is more on, more on nurturing, something like that, more on sampling, and you take care, just like a medical technology, right? I don't know really the exact rules and responsibilities of being a nurse, being also a medical technologist. But I understand being a medical technologist, you will get blood sample, urine sample. They're more focusing on the laboratory test results. But this nursing is all about, treatment, assisting the doctor, okay, getting the BP all the time. Based on my personal experience, yeah, caring, what to do, assess the doctor, something like that, nurturing, but it's not on the laboratory tests. You have also to learn about what the medical technologists are doing so that you can also use that in your profession as a licensed nurse in Grand Canyon University in the Arizona. Wow, perfect. Thank you so much, sir, for tuning and passing in my YT live streaming. I have an international student right now. Oh my gosh. So it's good that you are here in my live streaming. Okay, so just develop more about pure sciences. There's a lot of pure sciences, not limited to chemistry. We have physics, something like that. We have planetary science, geological science. Okay, the environmental science, like the forensic science. Okay, the pharmaceutical science. A lot, but the basis always are the chemical reactions and chemical processes, how it behaves to the certain area, something like that, especially for the life. So we have biochemistry, something like that. Okay, how can we produce also iron oxide or ferrichloride rusting process in the earth? Okay, that's another science, right? It's mineral science or biological science. Basically, under mining engineering or metallurgical engineering, something like that. If you're talking about the rusting process, RUSTING, okay, we create a scales out of those chemicals that will be deposited in the pipelines, something like that. Different corrosion, the pitting corrosion, like that. The iron corrosion. There's a reaction for that also. Usually involves iron, okay, the ferrous and the ferric chloride and plus the water, something like that. There's a chemistry for that also. Okay, so ganon. Okay, thank you so much. My gosh. Hello, guys. Okay. Wow. Butyric na tayo. Grabe ng butyric, oy. Wow. Okay. Butyric acid. Sorry ha. Let's write first the name. Ay, ako dyan. Butyric acid. Butyric acid. Okay. Butyric. Hala. Malulok kayo dito. Butyric acid. See? Ay, nako. Hala. Butyric acid. Carboxylic acid. Okay. So what? Sotero is butyric acid. So this is an acid found mainly on the batter. When we eat batter, butter, or what we call the ghee, GHEE, the clarified butter. Okay. It be created in our body, okay, during the breakdown of those good bacteria in our gut to break down the dietary fiber. Okay? Dietary fiber meaning the fibers that we receive in our body. For example, eating banana, eating wet bread, eating orange, like that. There's a fiber for those fruits and vegetables, right? So the function of this butyric acid, okay, this will be created from our body, okay, if this good bacteria in our gut meaning GUT, right? Not the GOT, huh? The gut meaning the large intestine and the small intestine, GUT, okay? And then breaks down the dietary fiber, like that. So that's the purpose, okay? Like that. So butter, butter, Okay, so most of the food have butter, right? Especially dairy products. Okay, the cheese, the milk, what else? A lot, right? Then through eating that one, we can obtain a butyric acid. Oh my gosh. So butyric acid, don't be afraid. Okay, because this health benefits are good, but you should not again overconsumption of eating this butyric acid in the batter like that, blah, 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 so on. So this is most foundly in the animals and plants. Okay, this is the most saturated fatty acid, less than the stearic acid, less than, because this butyric not too much carbon, something like that, compared to those saturated fatty acids, right? Only the carbon is only 4. Check. 4. Again, butyric acid has a formula of 4 atoms carbon, okay, 8 atoms of hydrogen, and 2 atoms of oxygen. Imagine only 4 carbons compared to those others that have so many, right? Okay, the stearic has 18 atoms of carbon, the palmitic acid that has 16 atoms of carbon, but this one is only 4. Okay, so see, this is not that very dangerous, but still undersaturated. Okay, if you eat this too much, then it is a problem. Okay, like that's fats. Okay, most saturated fats found in plants and animals, something like that. Okay, and then what's the other uses for this? Okay, this can be used in the making plastics, in plastics industry. Okay, but in one condition. Okay, you have to remove the hydrogen first. For example, this is a butyric acid. I have to remove the hydrogen in the process, so that is dehydration process, right? The product will be anhydride. The word "an" meaning without. Okay, in English, "an" meaning without, or the reverse for the reproduction, something like that, or the reverse for the propagation, production. Okay, is the breaking down, or make it lesser, something like that. "An" or removing it. So "an." So analgesic. Okay, removing the pain sensation. That's why we need to take analgesics, drugs, and narcotics for pain reliever. Okay, like that, to remove the sensation of pain. Okay, because "an" is without, and "gesic" is a pain. If you try to connect the word analgesic, okay, it's the same here, anhydride. Okay, removing the hydrogen to become anhydride, and that's the time it will produce a cellulose butyrate that is responsible and useful in plastic products. Okay, so you can remember now already that this uses, aside from the ketone, right? The ketone is used as a solvent for the manufacture and production of synthetic fibers and plastics, right? Ketone. Also, cellulose butyrate comes from butyric acid, useful also in making plastics. Okay, and now you know. And there's a lot also, polycarbonate, HDPE, high density polyethylene, plastics. I'm talking for plastics, Okay, so this one is an addition to our learning that cellulose butyrate coming from butyric acid that is already anhydride during the reaction will be responsible in producing plastics or used in plastics industry that are used now every day, something like that. Okay, so that is for butyric acid. I will show you the formula. Say for the good application, right? Only for the overconsumption is that negative effects. Okay, C4H8O2 char. Meron. Ito. Nakakaluka. Okay, let's try to remember if it is a saturated fatty acids or unsaturated fatty acids. Just remember, guys, that there's 2 atoms of oxygen in the subscript. It will not change all the time because it's only an attachment to the carboxylic group, which is the COOH. So the 2 oxygen there are an identification that automatically we have two atoms of oxygen already. So your problems now are carbon and hydrogen. I'm teaching you the technique. Okay, but this carbon will matter on the how many carbon atoms there. So it's also easy, especially like alkane, alkene, and alkyne. So your problem now is only the hydrogen. Then draw the structural formula and count the hydrogen. Then bingo, you have the exact formula of those organic acid. This is a technique. And the word also, for example, metha, okay, the buta, so 4, okay, etha, 2, okay, propa, 3. So it will become an acid. Just take not always the carbon and drive the functional group and substitute it there and count them there one by one. It's very, shall I say, it doesn't mean that I am a chemical engineer. It's easy for me, but I'm telling you that it's gonna be the pattern if you, so we will not be confused. Okay, it doesn't matter whatever profession you have. It's just only an identification that that's really the situation to be. For example, COOH, there's 2 oxygen there in the end corner of the saturated fatty acid. So automatic bingo, there are 2 atoms of oxygen. Your problem now is the carbon and the hydrogen. So hydrogen, forget that first. If you have the carbon, count that one and draw how many carbons. Then put the hydrogen bonding there in a covalent bond. Then you can exactly formulate the formula of that carboxylic acid or the long chain fatty acid, which could either be saturated fatty acid and unsaturated fatty acid. Okay, so how can I identify, Sir Sotero, that this butyric acid is unsaturated or fatty acid? The only one to identify that one, guys, is through the words, wordings, and plus we try to illustrate the molecular structural formula or the arrangement of that organic acid. Okay, so it's not good to memorize also. Okay, just discover, because sometimes also the word very confusing. I told you for the carbohydrates, for example, it also says that monosugar. An example for that is dihydroxyketone. Dihydroxyketone, why is a sugar? It's a ketone. See? So sometimes you will be confused also that this family will try to go in that family, nakisawsaw siya doon. So that is, dihydroxyacetone is a ketone family in the first place. But you like to go there in the sugar family, in the carbohydrates. You know what my point also? Just like that. And another also example, see aldehyde, okay, is another family. But why he also go there in the aldoses family, in the sugars family? We have glyceraldehyde. See? So sometimes they act in dual functions, in mutual functions. The only thing you have to understand is through their molecular structural formula, because sometimes they have the same number of compositions and number of atoms, will differ only to their behavior, the way they behave in the reaction, the structural formula, and the arrangement through their properties also. So those are called isomers. Okay, the same molecular formula, but differ in their molecular structural formula and differ in their properties, how they behave. What are those properties? That's specifically referring to the physical properties. So what are those physical properties, Sir Sotero? Those are boiling point, melting point, okay, specific capacity, diffusion rate, something like the density, the specific gravity. Okay, these are physical properties. It's not the chemical properties, right? Okay, like that. Okay, so the way they live is already a chemical properties, or a chemical change. But this is physical properties. These are physical properties. The humidity, also the high temperature, meaning the parameters, specific environment parameters, in order for the substances to grow or to be inhibited. There are only two, right? Substances to be grow and activated, and substances to be deactivated and inhibited, meaning it will not function. Okay? So, without propagation. Something like that. Okay? Anabolic or catabolic? Okay. Remember catabolic and metabolism. Okay. Yes, because larger molecules, so we can say it will be inhibited, like, okay, destroyed. The big molecules will be destroyed to become lesser molecules. It's just the same It's just destroying the large molecules like that, right? So if this is a large atom, the glass, and I will destroy this to become smaller atoms, and I have to throw this to become broken. So that's the principle of anabolic metabolism. Okay, because the catabolic metabolism is other one. Okay, my gosh. Okay. Really? Yes, metabolism. Motion. Ganun, with the propagation talaga. Okay, C4H82. And also, Sotero, how can I use the molecular structural formula for this? We apply the RCOOH, the carboxylic acid. Okay, wait. Ganun lang siya. Okay? Because, wait, C, double bond oxygen, and then we have the OH here, something like that, and we have 4 carbon. Okay. So 1, 2, 3, 4. Okay, like that. Okay, COH, then we have the H. H, 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 H. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is. Okay, this is the butylic acid. Okay. 4 carbon atoms, and the rest will be hydrogen, and incorporating the COOH, the carboxyl. It's here in the carboxyl group here. Okay. Like this. Okay, structural formula, right? Okay. So like that. The other definition also, for example, oleic, right? Oleic acid and linoleic acid and stearic acid, both of them have the same carbon atoms. The only identification, right, is their, aside from the molecular structural formula, the arrangement, also their molecular weight also. Something like that, okay? Because the more it has the double bond, the more it is hard for that to break. Okay, meaning to say it needs more energy to break that double bonds into a single bond. So the more energy needed for that, meaning to say, if we try to take an example, the physical property known as boiling point. If we put stearic acid in a vessel, let's say flask, and we put the oleic acid in the flask 2, and the flask 3 is the linoleic acid. So the boiling point will not be the same. So that's what we refer to different properties. Okay, that's boiling point. Now, normally, the one that has have a very, very high molecular weight, very high, or the one that involve a double bond or a triple bond, it's very, very hard to break the double bond into a single bond, means it requires energy. So heat is an energy to break that bond. After breaking that bond, too much energy needed. So too much high boiling point is needed for that. So meaning to say, the boiling point of linoleic acid is higher than the oleic acid. The boiling point of oleic acid is higher than the stearic acid, but they have the same molecular formula, something like that, which is have 18 carbons, atoms, the same. Okay, the same 18 carbons, something like only the bonding. Okay, like that. You understand the point? Okay, because the more you have the bonding also, and the H will matters there. Okay, so normally because the H will become lower if there are double bond. Okay, like that. The more it has double bond, okay, the more the boiling point will rise. Okay, like this. Or in another compounds, not only referring to fatty acids, in other organic compounds also, the only identification we need to understand if that is a higher molecular weight, so it's too much boiling point needed, too much energy needed to break their molecules apart from each other, and then normally they are heavier if we have higher molecular weight. Sometimes you have to analyze also. We should not memorize that because there are questions also in the examinations that like that also, especially the periodic table, right? So which of the following has a higher ionization energy, like that? which of the following has high electronegativity? You should think also the formula that have more electrons, something like that, in the outermost shell. Because if they have higher number of electrons to the shell, meaning he is highly electronegative than the others. Something like that. So even though sometimes it's not being discussed, in detail in our college, in our high school, then you have to have your own ability to discover what's really the principle behind for that. So that if there are very difficult organic compounds that you encounter in the future, you can really understand the basic foundation, something like that. And this basic foundation of chemistry, the number of electrons, the number of protons, the octet structure, the Lewis dot structure of bonding, okay, the octet rule, something like that. Okay, you remember that one? So it's very also necessary in organic chemistry. If you remember that one, orbitals, sp orbitals. So there's a purpose for that. Okay, so we need to use that in organic chemistry also. Something like that. Okay. So I have no time to discuss it properly for that. So because a lot of topic in organic chemistry, right? So that's butylic acid. You already know that here. So it's only in half upon my discussion. It's not really the focus. Something like that. Okay. So like that. My gosh. So tapos ako sa butyric ha, and now we go to, what time na? Time check. Grabe. Okay, time check with your powder. Alas ka na. So, let's go to the, malic acid. This is very important also. Okay. So malic acid found in fruits. Okay. This is very, very important. Okay. So malic acid found in fruits. Okay. This is very, very important. Especially in food industry. This will be used as a food additive. Okay. Food additive name, enhancing the flavor. Okay. The flavoring of a certain food will matter if you have malic acid. Okay, so this malic acid came from the fruits. The identification for that, when you buy a lemon, when you buy an orange, or any kind of citrus fruits, if you feel the sourness, S-O-U-R, of that fruit, so an evidence that the malic acid naturally present in the fruit. Again, if you try to taste the citrus fruits or any kinds of fruits, and there is a sour taste in eating that one, that means there's a proof that malic acid is present to that. Okay, and then this malic acid is very important to be used as food additive and flavoring enhancement and flavoring of the food material. Okay, so that it will become tart. Tart again, T-A-R-T, flavoring of the food material. Okay, so that it will become tart. Tart again, T-A-R-T, tart. So tartness, yes. That's meaning a combination of being sour and being acidic. Okay, because there are also acidic that is not sour, right? Am I correct? Okay, but most of the sour are acidic by nature. I think so. Okay, naturally. Okay, sour and being acidic is tart or tartness. So, for example, at the foods, right? The neutralizing and balancing the sugar and the cream. For example, if you make macaroni salad, something like that. You just don't know, but the malic acid is already there. Okay? You don't know because that is not your focus. Your focus only is to achieve a very tasty food, right? So that you can eat properly, so that your tummy will be full. But it's in there already, the malic acid. Okay? So you balance it so that the sugar paste and the creamy will be adjusted. So the tartness flavor will be there. Okay? I think spaghetti also, you have to be, a little bit sour, not too sweet. So this malic acid will exist in the kind of situation. in the food substances and the sweet and the creamy substance, something like that. Okay, so this is the purpose of malic acid, the application of malic acid. So the malic acid molecular formula: 4 atoms of carbon, 8 atoms of hydrogen, and 2 atoms of oxygen. They know there are also 2 atoms of oxygen because malic acid is an organic acid for the carboxylic group COOH. So there's a 2 and troubleshoot that one also. Okay, so I will try to illustrate the malic acid molecular structural formula. Let's see. Okay, and we'll try. I will done with the application. Okay, like that. Malic acid. Again, from the esterification of water. Always like that, ha? In organic chemistry, the acids will be produced by esterification. Esterification of the salt to water. Okay? And the product will be always, the acid and the base. Okay? Just like the inorganic chemistry. Okay? But it's more difficult in the formula of the so many. Okay, like that. Okay. Acid. Which illustrate guys. Okay? Oh my gosh. Talaga yun. Okay. Malic acid. Okay, this one. So, C4C6H5, no? Dami ko ng mga scratch papers. Last na niya, malic acid. The other one will be part 2. Okay? Dahil kaya acid, hindi maubos. Okay? So this is malic acid. Okay. Malic acid C4H5. Not O2O5. Because the molecular structure formula, I told you, the only way to correct the structural formula, that's why. Okay, we need to do that. Because if we don't know, how can we identify the proof if it's correct or not? Okay, so like this. 1, 2, 3, 4, 5, 6. Like this. Okay. This is malic acid. Wait guys ha. Kasi 4 carbons po kasi siya. Okay, so I have to draw muna carbon. 4 carbon atoms po siya. Okay. Like this. Ganon. Okay. Okay. Malic acid is this. H. Halakajun. Okay. Oh. Ganon. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. So there's gonna be double band. Something like that. Okay, so like this. Double band. And then double band. So there's a double band in the carbon. Okay? So you can adjust the double band already because if you try to take note, it will not be balanced. Okay? Something like that. And you always take the reactions, the number of atoms, something like that. So actually, this is the first time. Sorry for the first time I illustrate the this organic composite. Not prepare kasi. Okay? So that's why. So let's say 4 carbon like this. It's easy to plug if you prepare, right? So it goes perfect for me to prepare the, the like this. So So there's a chance that I will be confused, something like that. Okay. So this one, OOH. So relying only my, brain capability, something like that. Okay. Like this, like this, like this, like this, like this. Okay. H, H, like this. Okay. Like this, H, like this. Okay. 1, 2, 3, 4, 5, 6. Like this. Okay. And like this. Oh, really? Like this. And then we have oxygen 5. So we have the double bond here. Well, charot. Talaga, double bond here. So 1, 2, 3, 4. Ganun siya. Mm. So 1, 2, 3, 4, 5, 6. Ganun siya. Oh, ganon. So, as OH. Okay? So there are 5 OH, oxygen. 5 oxygen. Okay? So, COOH. R, di ba RCOOH siya? Okay? R, mono siya. Masaya siya. Sorry. Because, sorry. Because, my tongue was twirled. Shut up. So C4H6O5. Okay, like that. C4H6O5 is for malic acid. Then, if you found out, guys, that even though you really establish the molecular structural formula, okay, there's a time, this is also technique, there's a time that it will not be okay because there's an incorporation of the benzene ring or the aromatic hydrocarbon. Okay, that's why if you keep on trying to illustrate the molecular structural formula, it will not be the same with the general formula because there's a benzene ring or a polygon basis, which is a penta and the hexa. In organic, always like that. Benzene ring and the penta ring, something like that. Okay, so exemption for that is benzaldehyde, okay, formaldehyde, mga ganun siya, acetaminophen, okay, adenosine triphosphate, okay, nicotinamide, adenine dinucleotide phosphate in ADPH, okay, nicotinamide, adenine dinucleotide, mga ganun. Okay, ribonucleic acid, something like that, deoxyribonucleic acid, which is the DNA. So not all the time that you include only the elements. Sometimes the benzene ring, the polygon, something like that will be incorporated there. That's why it's very difficult to imagine. Okay, sometimes that, oh my gosh, it's gonna be like this. It's gonna be the wrong one. Okay, see, there's a benzene ring, something like that. Okay, so ganon. So the formula is C4H6O5 for the malic acid. Okay, thank you so much for watching, guys. It takes me a long time to vlog this. And imagine I have only taken 4 to 5 acids, and there's a lot of acids in our environment, right? Or inside our body. Okay, thank you so much for watching, Mr. Ski Monster. Thank you so much. Yes, because my topic is very lengthy, and I'll try to connect the other topics also. Okay, so that's okay. So my topic is acids. Acids are my topic. Okay, like that. Okay. Thank you so much for watching. If you think you like this video, next to me, you can comment and like this video and click the notification bell or some news updates of I Am a Singer, Eternal Voice. Okay, bye bye everybody. Get blessed. Okay. Yes.